This is fire. These flames might be those produced by the fuel supplying heat for your home, or those in a furnace churning out steel for a new super aircraft carrier. But when out of control, these flames could engulf your aircraft, destroy your aircraft carrier, your home, or even you. But whether controlled or uncontrolled, fire requires three elements to keep it alive. One of these is fuel, another is oxygen, and the third is ignition temperature, the temperature at which fuel and oxygen will ignite through a chemical reaction. No fire can exist without all three of these being present, like the three sides of a triangle. And whenever all three of these elements come together, certainly there is a fire. Simply removing any one of these three elements puts out a fire. To better understand the nature of fire, let's first talk about fuel. To begin with, most materials that we use daily must be considered a source of fuel. It isn't the material itself, but vapors given off by the material that burns. For example, wood shavings placed in a flask and heated will evolve vapors which can be ignited. This is true of nearly all materials, whether in a solid or a liquid state. When heated, these materials produce vapors, and the vapors can be ignited. Many solids first go through a liquid state before vaporization takes place. With a candle, for instance, the ignited wick melts the paraffin into a liquid. The liquid is drawn into the wick and gives off a vapor which feeds the flame. Even when this candle is snuffed out, vapors are still given off in sufficient quantity to be ignited at some distance from the wick. These two liquids have been heated to a temperature at which they begin to give off vapors that can be ignited. This temperature is known as the flashpoint. For instance, number 1 fuel oil has to be at approximately 106 degrees Fahrenheit to reach its flashpoint. Diesel oil reaches its flashpoint at approximately 145 degrees Fahrenheit. At these temperatures, these liquids give off vapors that can be ignited readily. Some liquids have very high flashpoints, while some have flashpoints so low that even at room temperature, they are constantly giving off highly flammable vapors. Gasoline produces vapors at temperatures as low as 45 degrees below zero. Although not visible to the human eye, these vapors may be revealed by means of a shadow image. The vapors, being heavier than air, overflow the beaker, even when the beaker is only partly filled with liquid gasoline. That's why liquids such as these, which vaporize at low temperatures, always present a fire hazard, thus must be handled with great care. Nevertheless, even the most highly flammable vapors will not burn without the presence of oxygen. On the other hand, with enough oxygen, even steel can be made to burn. First, a beaker is filled with pure oxygen. A lump of steel wool held over a flame will only glow, but in contact with sufficient oxygen, it burns readily. Ordinarily, the oxygen required for combustion comes from the air. For example, the air surrounding this candle. But when the candle is burned inside a glass beaker, the supply of oxygen is gradually consumed. The flame will diminish and go out. To further illustrate this point, we'll fill this beaker with carbon dioxide. A wooden splint immersed in the gas will go out. When the splint, while still hot, is once again surrounded by air, the oxygen in the air reignites the splint. Another demonstration using this electric sparking device. A spark below the surface of the gasoline will create vapors, but it will not ignite them since there is no oxygen present. But above the surface, where the vapors mix with air, the same spark ignites the vapors, again illustrating the importance of oxygen in supporting combustion. Now the third element, ignition temperature. This number 1 fuel oil has been heated to its flashpoint, 106 degrees Fahrenheit. And as we know, this means combustible vapors are given off, which combine readily with oxygen. However, combustion will not occur until the ignition temperature of the vapor-oxygen mixture has been reached. Common sources of heat to produce ignition temperature are a flame, an electric spark, and this heating coil. However, ignition temperatures vary for different materials. This hot soldering iron demonstrates this. Gasoline requires a higher ignition temperature than is normally produced by a soldering iron. But paper, having a lower ignition temperature than gasoline, instantly ignites. And the heat of the flames, in turn, is hot enough to ignite the gasoline vapors. On the other hand, a vapor-oxygen mixture can also be heated to such a high temperature that it will ignite spontaneously. This temperature of a fuel is called its self-ignition temperature. Another example of self-ignition with Stoddard solvent, a common solvent used for cleaning purposes. A welding torch is used to heat this steel plate. Although not in direct contact with the flammable liquid in the beaker, the steel plate will finally get so hot that it will bring about self-ignition of the vapors. Since the heat of its flame is greater than the ignition temperature of a fuel, a fire will spread rapidly once it has gained headway. However, a flame applied directly to this heavy fuel oil goes out, because the temperature of the fuel oil is still below its flash point. By pouring a small amount of gasoline on the surface of the oil and igniting it, the heat of the flame is sufficient to raise the temperature of the heavy oil to a point where vapors are produced. These vapors then are readily ignited by the flaming gasoline. So far, this video has shown you the parts that fuel, oxygen, and ignition temperature play. Anytime these three elements are brought together, you can expect a fire. You can prevent a fire simply by removing or eliminating any one of these three elements. Now we shall first consider the control of a fire by the removal of fuel. In a tank or vessel filled with gasoline, a fire such as this will be extinguished by draining the gasoline out of the bottom. Just as turning off the supply of gas to a Bunsen burner will cause the flame to go out, so ignited vapors coming from a vent can be put out by shutting off the flow of fuel, which stops the flow of vapors to the vent. Now observe that the elimination of oxygen will also stop a fire. By covering this beaker of burning gasoline, oxygen will be eliminated and the fire goes out. Oxygen can also be eliminated by displacing it with carbon dioxide, an invisible gas widely used in fire extinguishers. A fire can also be stopped by the removal of the third element, ignition temperature. This wood fire is extinguished by a fine spray of water, which cools the burning wood below its ignition temperature. The flame of a Bunsen burner can be made to go out with a fine wire mesh screen. The screen conducts the heat away at such a high rate that the temperature of the burning gas and air mixture falls below its ignition temperature and the flame goes out. Dear viewers, in this video you have seen how the presence of these three elements will cause a fire. You have also seen how you can put out a fire by removing any one of these elements. Your understanding of the nature and control of fire, plus constant vigilance, are essential if you want to prevent the loss of lives and property due to fire. Thanks for watching. Please subscribe my channel for more safety videos.